Well, thank you, Carson, for that excellent talk. It literally has blown my brain. I'm going to be going over it again and again and definitely playing with that code. So we've got some great questions here. The first one is, what is proximal policy optimization?
Yeah, so it's one of the many algorithms in reinforcement learning. This is the one that I think is commonly used with RLHF. And the proximal means uh
RLHF,
oh,
just
sorry, reinforcement learning from human feedback, which is the method that was used to train ChatGPT and Instruct GPT, which is its predecessor. Yeah. Yeah, basically when you're using instead of training a model to essentially, I wouldn't say memorize is kind of, yeah, maybe memorize a bunch of data. You tr instead train a model that tells whether the model is doing a good job or a bad job, and then you use that model from a reinforcement learning sort of pipeline to train that model to do more and get and score higher on that reward model. And so PPO is the one that's common. You can use other models besides PPO to do RLHF, but this is one model, and it's called that because one problem that the reinforcement learning community is still dealing with is trying to get reinforcement learning to be less noisy. Like a lot of these video game, if you read like how they trained these video game reinforcement learning agents, it runs for a very long time. It's not like human beings. Like you show a kid a video game and they'll play around with the joystick and they'll figure out how to play the game fairly quickly. Like they're not going to play the video game for millions of hours or something like that to figure out how to jump over like this pipe, if you're Mario. So the way the PPO means that um, it's allowing the model to not sort of uh, what's called distributional collapse, which means it's very easy to update models in a way that destroys how the model is functioning. And kind of like, for example, if you imagine you could never well you should never say never, but it'd be really hard to do this on a real car because that car would just be crashing into the sidewalk, crashing into poles all the time. You would have to buy like a lot of cars to train it in real life. And so you want a car that like sort of drives okay, and then like you keep it and then you teach it to do what you want it to do better. But you don't want it to lose too much of its original, I guess, knowledge or behavior. So that's when you want to stay proximal to its original behavior with a slight adjustment. Yeah, sorry if that was a little too.
thank you for that
Yeah.
explanation. I mean, I think it just goes to speak about the complexity of these underlying technologies and approaches that are being used. It's like the end result feels like magic, but there's a lot going on under the hood. I think that's my take on this. So the topic of sentiment, how do you create positive versus negative sentiment? And I guess what this is really talking about is, when we think about these models and we think about machine learning, how does it know the difference? What does that even mean?
hmm So this goes back to something that we were talking about in like I guess what do you call it, the back room, like while the conversation, while the talk was going on. This is a lot of simplifications had to happen to make this mini chat GPT work. And by the way, this is taken from I'll say this again, and I said it before. It's taken from Leandro von Wera's GitHub repository, which is from Hugging Face and from OpenAI. I want to be very transparent that like I didn't do this all myself. I don't want to give proper credit to the proper people where credit's deserved. Um, but a lot of simplifications were made. For ChatGPT, what they had is they had a bunch of data where there were instructions and then answers to those instructions, because that's what you're doing on the OpenAI interface is you're telling it to do something for you or to write something for you, and it does a good job of it, or usually a good job of it or a bad job of it, and that's the reward. We That's a very complicated task, like instructions and answering. And so in order to put that into a toy model, instead of instructions, we're putting the beginning of a sentence that's incomplete. And then instead of the answer, we're having it do something simpler, which is just complete the sentence. But the definition of good in our case for the mini ChatGPT means the sentiment is positive. Whereas in ChatGPT's case, the meaning of good means it's a really good, like thoughtful answer that is non-toxic and safe and but also helpful to this instruction. And so those are the simplification. That's like sort of the simplification that you need to allow me to like, explain the mechanics in this mini version. But the way it was trained is there's a lot of prior to ChatGPT, there's already a lot of data out there. This one uses the IMDb data set where people are like scoring like on a, 1 star means I don't like this movie to like 5 stars means I really like this movie. And they have these star ratings along with like what they wrote. Like, this is a boring movie. It's like formulaic and like I've seen it 1,000 times already in different forms. And that's an example of a bad review. And then other ones are saying, although it tends to be repetitive, the CGI is amazing and like it's worth it just for the visual effects on its own. Like, so that's an example of a positive review. And so they were able to correlate this reward, the number of stars, with what was actually written in natural language. And so a reward model that's different from the policy is trained just to assign like just to assign points to writing. This sounds like something that's positive, this sounds like something that's negative, and that's all it took to train a reward model.
Yeah, I think this whole topic is really fascinating because when we talk about things like sentiment, at the end of the day, this is all patterns. Like what makes, when you look at, even as a human being, you look at a phrase and it's like, why do you get a good feeling or a bad feeling? It's because your brain is picking up patterns on the kinds of words that were used. And it's
Hmm.
like at the end of the day, when machines start doing that, they don't have emotion. They just know patterns and they know that, oh, I've been taught when I see this pattern, that means this. And I've been taught when I see this pattern, that means that. It's really fascinating.
Yep.
Next question. You said that ChatGPT's data set is a large collection of instructions. I thought ChatGPT started ChatGPT. Oh man, they need a name that flows better. Can we just like abbreviate it like CG or whatever? um, I thought it started with a huge data set of words. What's the difference between like words and a collection of instructions?
That's just a really good question, Glenn. So uh, at least in my talk and the way that I will use the words, I'll separate pre-training from reinforcement learning. So all these models, they don't start off with randomized parameters at the beginning of their training. They started off first with a model that had already been pre-trained. And when I say pre-trained, I mean like I talk about this in my talk where first it learns, it's not learning how to write proper grammar, for example, at the time of reinforcement learning. It comes into that part of the training already knowing how to speak in proper grammar, and to how to compose words correctly. What it hasn't learned yet is how to answer instructions in a way that's satisfying to people. What it doesn't come in to that training with is necessarily a notion of what is safe or coherent, or effective or helpful. These are kind of the more hard to encode desires that we have. That is why we came up with RLHF in the first place. But it's just completing the sequence, like uh an apple is the color. You know that the probability distribution is pretty much going to be centered around red and green because apples tend to be red and green, and there's going to be a low probability distribute mass assigned to purple or like cat or whatever. But that is how it speaks in proper grammar because the probabilities are always going to be assigned to the next token that has grammatical sense. And reflect what it's learned in the training data. But what hasn't been encoded yet is our desires. Like you need to make it lengthy enough, and you need to be thoughtful about it. You need to refer back to the instructions that I gave you. So that's the reinforcement learning part. But the reinforcement learning part, if you read the Instruct GPT paper, they call it supervised fine tuning. So that's actually 3 parts. There's like I trained it on all the internet. It just learned proper grammar, and then I trained it on like a more specialized version that has instructions. So it has more of an instructee, answery kind of a feel to it. And then I trained you on a reward model with reinforcement learning to like really make you do it in a way that's that's satisfying to people because there's more than one way to answer a question correctly, right? And there's more than one way to pose a question. There's more than one way to answer a question, and there's more than one way to answer a question well, and there's more than one way to answer a question poorly, which is why the supervised fine tuning is, I mean, this might be the reason why, but maybe that's why supervised fine tuning doesn't really get you all the way there, and you have to do this reinforcement learning to just let it generate on its own and then just give it rewards.
Okay,
Yeah.
we've got time for one last very quick question, quick answer. Um, how much does the negativity or positiveness of the query to ChatGPT impact the negativity or positiveness of ChatGPT's response? Like, are we leading
Yeah.
it?
That's a good question. I think, I haven't tried this too many times. I haven't done a rigorous study of this on my own. So if you implement if get clone the repository, you should try this experiment. It'd be a really great thing to do to like really make sure you've learned it well. I suspect that if you give it a sentence that starts off very negative and it knows it's trying to make it better, it'll just have to do its best. It'll be like this movie is quite formulaic. Like in my previous example, if you started like this movie is pretty boring, and then you let the mini ChatGPT continue, it'll probably say like, however, right? However, towards the end, it pulls it together and like surprised me in ways that I didn't anticipate in the beginning. Something like that. I'm just making this up, but like it should, if done correctly, try to recover because it knows that its job is to create positive sentiment. But I'm sure you've given it a harder job by starting it off that way. But you should try it yourself. Yeah, I hope it works well. Yeah.
Thank you
Right.
so
Maybe we can
much,
all,
Karsten. Yeah,
yeah, maybe
go
we
ahead,
can all
Thank
Tabby.
you.
challenge ChatGPT with that. And we have a couple answers to your question, Glenn. We have for easier names, Chatty or Clippy 2.0. But thank you both for this. And let me now introduce our fourth and final speaker, Jun Ling Hu. It's a pleasure to introduce her and give a talk about the science behind chat GPTs. We're going to take this back out of the code and the math up to a higher level of the science that behind this that makes chat GPT possible.